Hey math kids, today we're going to talk about the area of a triangle, and we're doing example 1. We're in section 8b in your book. Before we get to that example though, I just want to stress what the base of a triangle is. So if we have a right triangle, or if we have something like this where we could draw a right triangle like this is from your book, you can look at it. And then if we had a triangle that looked more like this, your base, so this is your base, this entire thing is your base, this is your base. The height is a little bit different. It's like the perpendicular height. So on this one, it's just that simple. But if we just saw this triangle, we don't use this or this. It's actually the distance from here to here is the height. And then this one's even stranger. We'd have to draw something down like this and make perpendicular with this base, and that would be our height. Okay, and the area of a triangle is 1/2 base times height. Okay, some naming conventions for triangles. So if we call this A, B, and C, all with capital letters, we would need to name the sides lowercase versions of those on the opposite side. So the side that is farthest away from each one. Okay? Now we're going to move on to example 1. And it just says find the area of this triangle. So I have 28 degrees, 15 centimeters, 11 centimeters. I wonder if I just missed this in the book. Oh, they do mention it. Okay. So when I was doing that brief explanation at the beginning, I didn't see the part where they do the other area. So it's 1/2. Let's see. 1/2 AB sine C is another version of the area of a triangle. And so the important part about this, so it doesn't matter which one's called A, which one's called B, or whatever. It's 2 legs or 2 sides of a triangle and the included angle. That's the important part. Okay. So even though this one would be called C, and even though this one would be called A, and this is actually angle B, which looks like it doesn't fit into this, for the formula, I would just call this one A, this one B, and this one capital C. Okay? And once again, how we should think of this formula, it's the area equals 1/2, just any side, times different side, and then sine of the included angle. Okay? And so when we do that, we just get 1/2 times 11 times 15, and then sine of 28. And since it's given in degrees, make sure your calculator is in degrees. I think my calculator's frozen, so I'll just open it up again. Alright, so I'm going to just type in 0.5 for the 1/2 times 11 times 15 times sine, whoops, I actually got to put it in degrees. So you go to your mode menu, go to degrees, get out of it. Alright, so 0.5 times 11 times 15 times sine of 28. Okay, so for that one we got 38.7. And it was in centimeters, so that'll be centimeters squared. Okay, moving on to example 2. It says a triangle has 2 sides with lengths 10 centimeters and 11 centimeters. Okay, so I'm just going to draw a triangle, say 10 and 11, and an area of 50 centimeters squared. Determine the possible measurements of the included angle. Give your answers accurate to 1 decimal place. Okay, so this would be the included angle. And so we go back to our A equals 1/2 AB sine C. So we do area, which is 50, is equal to 1/2 times 10 times 11 times sine theta. So we're trying to find theta. So if we multiply this out, 1/2 times that is 5. 5 times 11 is 55. And then we're going to divide by 55. And so we have sine theta equals 50 over 55. So to undo that sine, we do an inverse sine on both sides. So in our calculator, we want to plug this in. So I'll move, let's see, kind of in the middle of the screen. So second sine, then we get 50 divided by 55. And so we get the angle of 65.4. Now, if you look at a unit circle, I think that's how I want to show you how to do this. So, if we look at a unit circle, and 65.4, so we don't have to be exact, but remember the sine value, we had this thing, cosine theta, sine theta. The sine value is the y value. And so the same y value is going to show up if we use this angle as well. And so if we think of it like this, if we had 65.4, which would be this, we could figure out what this angle needs to be to get to 90. So we just say 90 minus that. Oops. So 90 minus 65.4. So 24.6, which means this is also 24.6. And so if we do 90, because this angle would be 90, so 90 plus 24.6. Just add 90 to that. We get 114.6. So that's the other one. So if you need additional help, please come to Math Lab. Those are the two answers. And for now, calculator.